introduction, Lorian. And let me share my screen. And can you please confirm that you can see my slides? Is it good?
Yes, but not
Yes.
yet in presentation mode.
Okay, now it should be fixed. So the topic for today is resilient stress testing of global supply chains. And I am Ilya Jackson from MIT Center for Transportation and Logistics, a research scientist. And my research is centered around applying advanced analytical techniques like machine learning, network science, AI, to solve supply chain problems in general. But one I'm going to present today is very global, very large scale, and has various applications that we can discuss. And I take questions during the presentation. So if something is not clear, you need more inputs, or you want to share something or ask questions, don't hesitate, right? Don't hesitate to interrupt me. So the research question, the question we try to answer is very straightforward, but also very burning for companies and governments. Like, what happens if my supplier upstream is disrupted? And the issue is that the visibility of supply chain is limited. Usually companies know their direct tier one supplier. And maybe if they do additional compliance and they dig deeper, they may know tier two, they may know suppliers of suppliers. But when we go deeper into tier, we lose visibility that may cause problems. And there are two very famous cases. One of them is a fire in Evonik plant in Germany. What happened is in 2011, there was a plant in the city Marl, Germany, which was producing a chemical that nobody really cared about. Its name is laurolactam. But nobody cared about this chemical, but this chemical was in bill of materials of another chemical. And this another chemical was necessary for another chemical, which was in the bill of materials of all lightweight plastics. And lightweight plastics is something that car cannot survive without. Yeah. So as the result of a fire in a small German plant, the whole automotive industry of Germany has been disrupted. And it required a lot of effort and a lot of collaboration between major companies like Volkswagen and BMW to coordinate efforts and resolve the shortage. Another example is something we could observe during the COVID-19 pandemic. When pandemic struck, many people started working from home, especially in the West, and they switched to home offices. And once you start working from home, you want to upgrade your workstation, you want to upgrade your setup. So people started buying tablets, laptops, upgrading phones, and there was a lot of additional demand in consumer electronics sector. So the consumer electronics took all semiconductors, all chips as input, and as a result, there were not enough chips for cars, for automotive sector. So it shows us an example of demand shock instead of supply shock, right? One of the industries took all the components, in this case chips, and there were not enough components for another industry. And what we can conclude based on it is that all industries are interconnected. For example, if we focus on oil and gas industry, which is big in Nigeria, right, as the largest industry, the largest exports of Nigeria. But if you think about it, it's essential for generation of energy. It's still a primary source of energy we use for transportation, for manufacturing, and so on. So without energy, not much can be done. But to extract and extract and refine oil, you need a lot of inputs as well, right? In the form of technologies, in the form of electronics, machinery, semiconductors as well, and so on. But to produce all these things, you need energy, right? So we live in a closed loop world. So the idea behind my research and the way we try to answer this burning question is to use various open access data sources. Fortunately, in the US, most of companies are public, and they have to file reports to SEC, Security and Exchange Commission. It's various audit reports, various earnings calls, and so on. Just maybe to show you an example, if we focus on a company like Tesla. Tesla files many reports, but one of them is so-called 10K report. It looks like this. It's a structured piece of text where business explains what kind of product it produces, what are financials like revenue, what is net profit. But what is more important, in this kind of documents, company frequently discloses some key suppliers or customers. So we know from this, from text mining of this document, we can retrieve information about who is supplier, who is customer, and who deals with whom. So on top of this, another data source is a proprietary database, Bloomberg, that also collects information about companies, as well as similar databases from Financial Times, Reuters, Yahoo Finance. If we combine it with data on international trade, like data from OEC, Bureau of Economic Analysis, we get a full picture of global supply chain, at least a snapshot of it, maybe not that detailed. So idea is that once we put all this text together, we walk through this text in fully automated fashion, like fully automated process. We walk through this text with Google API, and we scrap it all. So we put it all together as a piece of unstructured text. After that, we apply generative AI, GPT Turbo 3.5 in this case, to extract all the useful information from this pile of text. Like who is customer, who is supplier, what is revenue, what is relative trade volume, everything we can get. Once data is extracted, we put it to the database and build a network out of it. Yeah. So the end result is looking like something like this. We search for company like Tesla, my favorite example, and we see Tesla is located here in Texas at the headquarters of Tesla. Tesla belongs to automotive industry, and each connection, each edge of this graph shows tier one supplier of Tesla. Like there is this mining company, there is a bunch of companies in Florida, electronic components providers, electronic component. I don't have much information from Africa, unfortunately. A lot of companies from Asia. For example, Panasonic, they produce batteries that Tesla uses in their electric vehicles. But the idea here is that since I know tier one supplier of Tesla, like Panasonic Holdings, I can easily get tier one suppliers of Panasonic Holdings, like this. Right now, a focal company is a Panasonic Holdings, and all companies connected to it are tier one suppliers of Panasonic Holdings, right? But for Tesla, these companies are tier two suppliers, right? And tier two supplier for Panasonic would be a tier three supplier for Tesla, and so on. Yeah, we can unfold a global supply chain with this approach, right? Maybe I can check for some company in Nigeria. I don't know what is the largest company in Nigeria.
You want to check for Dangote?
How do you spell it?
DANGOTE.
It seems I do not. Oh, I do have it. I don't have much information because it's LTD, not shareholder society, but still we see it's in a database, and it deals with some company in Italy which produces oil equipment and services as well. some company in China involved in construction, right? So as you can see, the database is limited, mostly to US publicly traded companies, but still we have some other companies as well, but data may not be that complete. But I'm happy that at least it's in a database. Give me a second. So the idea is, once you constructed this network, what I did manually, moving from company to company, you can do all these manipulations in a fully automated way, which allows you to firstly illuminate or map to see supply chain you deal with, but also to run various scenarios, like what if company upstream gets disrupted, what are repercussions on my company. Yeah, and this kind of scenarios, they are known as stress tests. Yeah. So to give maybe a snapshot of data I already collected, with procedure I explained, I could get information on 55,000 companies from publicly available data sources. In total, I know 230,000 connections, supplier-customer relations, 93 countries in my database, and more than 270 industries. When we look on industry specifically, most of companies, more than 8,000 companies I have in a database, they belong to semiconductor sector, but also we have computer hardware, automotive sector, pharmaceuticals, auto parts, pretty much all sectors, but the focus was on electronics and semiconductors. That's why mostly I have companies in this area. We can map or illustrate supply chain and see who is supplier of my supplier. It helps company to identify various risks, for example, concentration risks. With this tool, I am able to see that in my tier 2, 90% of my suppliers are in China, right? And if I am in the US and this global trade tensions, they escalate, I may be at risk, right? What if there will be additional tariffs, or what if relations between countries get worse in the future? I cannot risk to have 90% of my critical suppliers in China. Some simple insight we can get from this, but there are other applications as well. For example, these days companies care a lot about sustainability, and part of the sustainability is to estimate so-called scope 3 emissions. Emissions not caused by me directly, but by my suppliers, right? For example, if I'm a company like Google, yeah, very software-oriented company, I don't deal with much hardware, so it's easy for me to be net zero. But when I build my servers, when I build my hardware, I rely on manufacturers of this hardware that may be located in other countries, in other regions, mostly maybe in Asia, and they may not be so strict with environmental practices. So to be fair, I have to account to emissions of my suppliers, because indirectly I cause this emission. I create demand for server, somebody builds the server, it creates CO2 or something like this. So eventually I'm responsible for it, but to really estimate how much do I indirectly contribute to emissions, I have to know this deep tier supply chain, right? So, kind of supplier of my supplier supply chain. Another application also on sustainability side is to get visibility to avoid some compliance issues, or to avoid some issues which are bad for reputation and just bad from human standpoint. Yeah, for example, there was a common, very loud case. Nike has been investigated, and it appeared that in tier 3 supply chain of Nike, there was a contract manufacturer in Vietnam that was using child labor, which is very bad. and Nike didn't know about it. And after this incident happened, Nike started to care a lot about what my suppliers and their suppliers are doing, creating more audits, and so on. Maybe case very burning for Africa, unfortunately, is a situation with conflict minerals. Unfortunately, there are wars and conflicts in some countries in Africa, like Congo or Mali, but there are still mining operations happening in these countries. So they maybe that some group controls some mining facility or oil extraction facility, and this group violates human rights, but at the same time, the raw materials they mine eventually gets sold somewhere, and it, as a result, it may appear in my laptop or somewhere, right? For example, something like cobalt maybe mined in Congo in a war zone and sold somehow, and I don't even know, but it eventually comes to stuff I buy. So these issues tool can also address. But the main purpose is a stress testing, is to simulate scenarios, like if something happened with some company like TSMC, what are repercussions, what is the effect on my company, let's say Saudi Aramco. To give more context, Saudi Aramco is the largest oil manufacturer in the world. They are located in Saudi Arabia, and the total evaluation of this company is over $1 trillion, a huge company. And TSMC is the largest contract manufacturer of chips, of semiconductors. And all our consumer electronics, from laptops to tablets to smartphones, cannot exist without TSMC. So these are kind of very big companies in their respective sectors, but they are not directly related. Yeah, TSMC is several layers far away from Aramco, and we want to ask, if something happens to TSMC, what are the repercussions? When we look at Saudi Aramco, we can visualize its network. As example, one of the tier 1 suppliers of Saudi Aramco is Siemens Energy, located in Germany. But we can do same step for Siemens Energy and see tier 1 suppliers of Siemens Energy. And all these companies would be tier 2 suppliers of Saudi Aramco, right? And if we move on with this technique, we can unfold the following structure, right? In tier 1, there are only 227 suppliers of Saudi Aramco. In tier 2, already more than 1,000 companies involved. And when we reach to tier 6, there are over 7,000 companies, right? And same with customers. Directly, not so many customer deal with Saudi Aramco, but as a result, a lot of companies eventually depend on oil, right? So now to specific scenarios. If we do stress testing, idea is that we remove a node from a network, right? Like we remove TSMC, or we remove a whole region, or we remove a whole industry. And in traditional network science, network is viewed as static, right? We remove node, there was a flow coming through this node, we remove node, and flow doesn't flow anymore, right? And we say, okay, that's it. There is no flow, we recalculate network. But this assumption is not very realistic, because real economy is market driven. If something happens to me, if I'm a company and my supplier is disrupted, I will not stand still. I will not wait until I get bankrupt. I will try to get more supply from existing suppliers. I will try to reach to alternative suppliers, somebody I don't have relations with, and to simulate this realistic behavior, similar to any economic agent, we take advantage of agent-based model. So idea is that every node of our network is an agent with some degree of decision making, right? For example, let's say we are here, we are Saudi Aramco, a node F, and we have a bunch of suppliers we rely on, D, C, G, and we have a bunch of customers we supply to, like H and K. So if node C is disrupted, there is no flow from C to F anymore, but the node F will not stand still. It will reach to existing suppliers D and G, asking to increase volume, as well as it will reach to new alternative suppliers, which currently it doesn't have relationship with. But the probability that supplier will agree to help you or not depends on bunch of factors like available capacity, available inventory, whether industry and sector are same or similar, and country matters, whether region is similar and country doesn't have any tensions with your country, right? So for example, if a potential alternative supplier is in Iran, we cannot reach to Iran because of tensions, yeah, something like this. In this case, what happened, G agreed to help F, increase supply, and the disruption stopped here, right? But if it doesn't stop, it causes chain reaction. Yeah, F, C was disrupted, it affected F, F may affect H and K, and they affect somebody else. It's like a chain reaction that propagates downstream. So once we build this setup, we can run a simulation and answer a question. So what happens if TSMC is disrupted? And it's a very realistic scenario because these days we see this kind of scary headliners, like from Wall Street Journal, that tensions between US. Oh, sorry, Philip. Was there a question? Yeah, if you have question, don't hesitate to ask. Yeah, but we right now we see scary headliners like this, that there are tensions between US and China over Taiwan, and unfortunately for the rest of the globe, most of advanced semiconductor manufacturing is happening in Taiwan. Yeah, and TSMC is a Taiwanese company. So if it's disrupted, in total in my network, over 300 companies severely disrupted. They experience severe drop in service level. Yeah, they cannot supply to their customers. And when we come to specific path of disruption, so what really happened, TSMC is quite far away from Saudi Aramco. Yeah, it's a tier 4 supplier of Saudi Aramco, but TSMC works with a company, Lattice Semiconductor, that designs specialized chips for control, for control of big equipment like gas turbines. But Lattice doesn't produce anything. They only design a blueprint. They send blueprint to Taiwan, to TSMC. TSMC manufactures chip. It's more complicated than I explained, but eventually chip goes to Lattice, and this chip eventually supplied to Siemens, and Siemens uses it for its subsidiary Siemens Energy to produce gas turbine that Saudi Aramco really needs for its operations, right? So even though there is no direct link between TSMC and Saudi Aramco, disruption of TSMC leads to severe disruption of Saudi Aramco. And when we look at global picture, because disruption doesn't stop at Saudi Aramco, it propagates further. So what we can see, disruption started in Taiwan here, and countries highlighted in red are the most affected. So mostly developed economies, large economies like US, Canada, France, Germany have been affected. When it comes to specific industries and sectors, mostly energy sector has been affected, but also basic materials, consumer product goods, utilities, automotive industry. As I said, mostly US has been affected. But in the US specifically, energy, utilities, and automotive have been affected the most. Yeah, even though disruption started with semiconductors. Yeah, it's not something we expect. We expect consumer electronics to get down first, but consumer electronics, on the other hand, is more prepared because semiconductor is a core component they deal with. So they naturally build larger inventories, and they naturally prepare more for this kind of disruptions. But a company in energy sector that doesn't deal with chips a lot directly is less prepared for this disruption. That's why energy sector is so severely affected. In this experiment, only one company, only TSMC, has been disrupted, but the tool allows us to disrupt a set of companies, a whole country, a whole region, a whole sector, and it may be helpful to simulate the potential effect of trade wars, because right now we see it's escalating. And for example, recently China put restrictions on exports of Lockheed Martin because it was supplying arms to Taiwan. So if China retaliates and puts some export restrictions or some kind of embargo, we may simulate this effect. Also, recently we experienced the pandemic when many countries decided to temporarily decouple from economy. And for example, China had a very severe lockdown, and we all could experience it, right? Like supply of Chinese goods has been decreased, and it resulted in a very high inflation. There are other factors of inflation, but one of the factors is that less flow of cheap goods from China. So to simulate one of these scenarios that may happen, this specific one is very extreme, very unrealistic. But right now, China by far smelts more aluminum than all other countries combined. Right? So what happens if trade war escalates? More and more trade restrictions are put on China. It decides to retaliate and puts aluminum embargo, stops exporting aluminum. Yeah, in this case, the situation is like this. Everything is red. Nigeria is not that red, but it's because I don't have much data for Nigeria. I'm sure everybody will be affected. So if country is painted in red, the disruption has been more severe, and all sectors ranging from technology and ending with consumer product goods, industrial goods, and so on have been affected. And that's like another capability of a tool. Yeah, we may simulate large-scale disruption, embargoes, pandemics, and so on. And we are not limited for any specific type of commodity or any specific type of product. One of the ideas I had is to apply this tool for to estimate resilience of food supply chains, because as you know, during the recent war between Russia and Ukraine, two things happened. One, the export of wheat has been restricted, and many countries globally, they were dependent on this wheat exports, so they experience shortage. And when it comes to food, it's not luxury. Shortage means malnutrition and food insecurity, famine in extreme case. But another problem is that Russia and Ukraine and Belarus also involved in this conflict. They by far produce as much fertilizer as the rest of the world combined, and many soils, they are not as fertile, and they depend on fertilizer to keep growing crops. And also to produce fertilizer, you really need a lot of energy inputs, and as energy due to conflict gets more expensive, fertilizers get more restricted. On top of it, you have issues with wheat exports. It's all may escalate a global shortage of food. So it's one of the scenarios I would consider next. Another potential avenue of give me 1 second. Another potential avenue is to go deeper to facility level, right? So for example, what you can see here are all various different mines across the globe, and it gives a nice it gives a nicer view compared to what I have now, because one of the limitations I have now, if you look at it, is my data is all at headquarters level, right? For example, when I check Tesla, I see Tesla's headquarters, which is in the US, in Texas. But in reality, Tesla has multiple factories, right? Yes, it does have factory in Texas, but it also has factory in San Francisco, and it also has factory in Nevada, and it also has factory in Berlin, and it also has factory in Shanghai, China, right? So my model doesn't account for it, because in reality, for most of international companies, operations scattered across the globe. But another problem I found is very frequently when it comes to raw materials, like mining sector, company may be based in some offshore island, like British Virgin Island, and company is in the general mining sector. Even though company's headquarters is located in some island for tax purposes, in reality, they own assets across the globe. A lot of mines in Africa, for example, a pit may be owned by a company, but company is located somewhere on island. Yeah, and model right now cannot account for it. That's why I decided to go to facility level data, to go to the level of plants, mines, and so on. On this map, you can see various mining operations across the globe, and they're differentiated by color. For example, purple stands for iron, and I see all iron mines. Yeah, like for example, in this corner of Australia. Or if we check South Africa, we see polymaterials, we see gold, a lot of gold. We see coal, green one is coal. We see some other mining facilities, right? And as a next step of my research, I'm planning to go to more granular level, to level of actual facility, actual mine where raw material is mined or extracted. So I think that's a brief overview of my research, and I'm happy to take your questions.
Thank you, Ilya, for the presentation. And yes, we can open up for questions. I know in the chat someone left one question. Maybe we can start there, and then people can start opening their mic to ask questions.
The question is in the chat, you say. Okay, I see it.
Yes.
We're looking at supply chains by company. Can you also look at supply chains by commodity type? Yeah, that's a good question. Right now, the focus is on company. But idea is to go more granular, to go to specific facility, and also to go to specific commodity, because you're right, even if industry is relatively simple, like mining, usually one company mines more than one commodity, right? For example, a simple, silly example, you cannot mine lithium without mining cobalt. So if you count company in your model, you should account for the fact that it deals with more than one commodity, right? And it may have shortage of one commodity, but enough of another commodity, right? That's the next step to go.
Thank you. We have Lillian who raised their hands.
Yes. Doctor, thank you very much for this presentation. It has a lot of depth. So I would ask you, how would a pharmaceutical industry or a pharmaceutical warehouse, not just a factory, use this information? I want to believe that this is like an app, and for you to use it, you need to input your own information, and then, input your own suppliers, your own customers, your own employees and all that, and stakeholders and people that get affected when one raw material is missing, or when transportation or whatever is lacking. So how would this be brought home to a pharmaceutical company, or a facility that has, like a country, for example, like in Nigeria, we have warehouse where we stock drugs for malaria, drugs for HIV. How do we get to start using this? Thank you.
That's a
I
wonderful question. Thank you, Lillian. Well, it's right now the tool has data from publicly available sources, right? So this 55,000 companies I have, they are already in the model, right? So if somebody wants to use this tool, it's up to them whether they want to enrich this data. So there is a chance that some of your critical suppliers and customers are already in my database. But of course, if you know more than me, it's your company, if it's a pharmaceutical company, I don't know, like BMS, Pfizer, Moderna, whatever, they know their operations better, so they can share information about whatever they know about tier 1, tier 2 suppliers and customers. I can add it to existing database and improve the granularity of the model. To talk about specific use case, right now the sponsor of this research is government. It's US government agency, and they care more about big picture, about national level. That's why the focus is on more like on geopolitical tension, on disruptions, on this kind of big scenarios, because right now it's designed so the end user is a government pretty much. If we talk about company, like in pharmaceutical industries, they probably need something more granular, as you say, level of specific warehouse, of specific facility, distribution center, and we shift to an area of network design. And I have a lot of colleagues and experts in network design. When it comes to this low level, like granular level optimization on the ground, it's usually a different kind of models that are used. Because idea here is you show big picture and you show high level risks. Your conclusion is at the level that you have a critical supplier 3 tiers away from you in geopolitically unstable region. It's something you have to address. But to give this recommendation, I don't really care about exact location of facility, about exact location of transportation infrastructure, right? I just say, okay, you trade with company, you have an important supplier, and this supplier is in China, and you don't have alternative supplier for this product. That's so far the level of insights the tool gives.
Okay, so it's still in database level. It's not exactly into an app that is because it's still government under government ownership. Yes.
We do not, like what I showed you, it's not really an app. So all code, everything is working, but we never put effort to build an app for it because it's more of a research project. And at least right now, there are no ideas to commercialize it or turn it into an app. There is nothing that stops us. So we can build app relatively quickly, but we just do not see much incentive right now. Right now, it's all about research. We want to push research as far as possible before deciding whether to create an app or something for end user.
Okay. Okay, so I also, this will be my last question, I'm sorry.
No, it's great.
I, I also didn't quite observe much comments on solutions. If it can profess solutions, or the user, when the data is put together and you see the risks, then you come up with your own possible solutions.
Yes.
Thank
So,
you.
yeah, that's an idea, because the risks we point out, there is no recipe to address them. So idea is we spot a risk, and after that, the executive board of a company or some organization makes a corresponding decision. But there is no much to do, right? If I tell you you have concentration risk, like you rely on some critical mineral, and all this mineral comes from Myanmar, for example, Myanmar, and you don't want to deal with Myanmar, I highlight flag risk for you. So natural reaction for company is to find alternative supplier somewhere else, if it exists, and if it's not that much more expensive. Or so the reaction of a company may be diversification, maybe to build more redundancy. Like if you have too few suppliers of some commodity, you build redundancy, you increase number of suppliers. Also, if end user of my product is a policymaker, like a government agency, it may help to address policies. For example, right now in the US, there is a strong sentiment towards protectionism, tariffs, protect our economy. And my tool can show something like that. Okay, we can put tariff, but what if countries we put tariff on, they retaliate, they put symmetrical tariffs on us, it will cut flow by, I don't know, let's say 30%. Here is the effect of this cumulative shortage. It's not good for US citizens, it's not good for US consumers. So when you design your tariffs and your foreign trade policies, you should account for retaliation, and my tool can show potential effect of retaliation. Like it's good for policymakers, or it's good for really big companies that have a lot of geopolitical risks, that have really global supply chains scattered across globe. I would say that's an end user.
Thank you, Dr. Ilya. Lauren, sorry for interrupting. I saw the comment from Tom Jackson. Somehow you guys shared the same last name. But while you were making your presentation, I just want to make a comment that I imagine that there are two major themes that I want to imagine. Localization is one key topic that we have been talking about on our platform, and localization also relates with regional manufacturing. So as Lillian was engaging you and coupling it with what you have shared earlier, I was imagining if it is possible that these two might just be a useful platform to synthesize and alternate global supply chain positioning that favors regional manufacturing. To say, if we use the same principle you had used for Tesla to do for a pharmaceutical industry, for instance, we may find out that a major concentration will be in Asia, and a major disruption will mean that, just like we had during the pandemic, we mean that there are no access here. And in supply chain, one critical factor for disruption is distance in terms of geography, technology, culture, and administration. So I was just wondering if you imagine that this tool can be additional framework to substantiate why there should be investment in decentralizing global manufacturing into regionalizing it to favor access to universal health coverage. Yeah, it's back to you. I was just trying to rumble so that you can think along with us.
No, that sounds great. That sounds like a perfect match. Yeah, localization is an ongoing trend. I mean, in every global policies, there are advantages and disadvantages. But long story short, if everything is localized, there cannot be global disruptions, right? So one of the interpretation of what my tool is showing is first, most of kind of scary examples, they are related to either monopolization, like company like TSMC produces almost all latest generation chips, right? Like one company globally produces all of them. That's one side of the problem. And if, as you said, if it's decentralized, the problem is not so severe. And another example is, as you say, distance is a big deal. When distances are long, you're also more vulnerable for disruption. So localization is a solution for both. I think in reality it's harder to implement because when it comes to, for example, semiconductors, I know this sector better. There is a lot of global labor division because technology used for semiconductors is very, very advanced. It's like sci-fi level, and it required billions and billions and close to trillion investment over decades. So the supply chain we have right now, it's very hard and expensive to rebuild from scratch. Of course, if we can start all over, probably countries like US, they will be happy to keep everything in-house. And even though it's a little bit more expensive, they would prefer to do it rather than to deal with risks. But practically, it's very hard to implement. And I believe in pharmaceuticals, it's the same thing. It's also very complex supply chain with very sophisticated R&D pipelines, especially when we talk about new drugs discovery from lab experiment to clinical trial to large scale manufacturing. It's also a long way, and probably many countries want to have the whole supply chain in-house because then it's you're less dependent. You can produce in-house, but it's hard. It's a lot of investment, and usually your market is not so big. I know population of Nigeria is large, but it's like 150 million, right, or something like this. So imagine if you have your local Moderna or local Pfizer that produces vaccine only for a market of 150 million people, the scale is different, right? It's very hard to make it cheap and accessible because your market size is small. But if you're an international company like Moderna and Pfizer, and your market is potentially 7-8 billion people, you can use return to scale, right? You produce a lot because your market is large. The relative expense of your R&D is smaller, if it makes sense. So that's something we may lose if we move everything in-house.
Thank you, Ilya. Thank you.
And there was a question I missed from Tom Jackson, and his question was, do I take steps to provide recommendation to address disruption from the standpoint of distributor or consumer of specific goods and the modeling those recommendations? We do. So when we do this project, we have specific focus. Like in my ongoing project focuses semiconductors, for example, and my customer is government. So I give recommendation on policy, but there is no way to automate this procedure, right? Because every industry, every sector is different. If I touch food or consumer products, my recommendation will be different, and I have to study domain, talk to domain experts, do interviews to make sure that recommendations that my model gives make sense, right? Because we before publishing something or before sharing recommendations broadly, because there is huge responsibility, it may affect policy. We try to consult with experts in field and validate results internally, right? So also regional focus is important. Imagine if you ask me to do some recommendation over I don't know, Nigerian oil industry, right? I don't know much about oil industry. I don't know much about Nigeria. I can run my model, give you recommendations, but they may not make sense. So I would need constantly people who know region, know industry to share inputs to validate my model. Usually it's a collaboration with somebody.